Welcome to The Explainer. So if you're getting started with Kubernetes, you have probably hit this exact wall. You've got your apps running in containers, they're all there, but how in the world do you get them to talk to each other reliably, without everything constantly breaking? Today, we're going to take that journey from a super fragile setup to one that's truly resilient. We're going to follow a classic debugging story here, starting with a problem I guarantee you've seen or will see. Then we'll build up, piece by piece, to the really elegant solution that Kubernetes gives us, hitting on pod IPs, then services, and finally, deployments. All right, let's dive in and set the scene with a scenario that is probably all too familiar. Okay, so you've done step one. You've containerized your microservices. Let's say we have a to-do app and some kind of progress tracker that it needs to talk to. And you've put them on your Kubernetes cluster. Now, each of those containers is happily running inside its very own pod. So far, so good, right? But here's where we hit our first snag. The to-do app tries to make a call to the progress app. Maybe it's a log that a new task was just created, and nothing. The connection just fails. The request never even shows up. The pods are definitely running, but it feels like they're in their own little bubbles. So what gives? How are we supposed to build a stable, reliable bridge between them? Now, a super tempting first thought, and honestly a very logical one, is to just find the pod's IP address and, use that. But let's walk through exactly why this is a trap that leads to a system that's doomed to fail. I mean, the process seems simple enough. You run a quick kubectl command, you find the progress pod's IP, you just pop that IP into your to-do app's config file, redeploy it, and hey, look at that. It works. Communication is flowing. Problem solved, or is it? Well, this little fix is actually a ticking time bomb. It exposes why we need things like services and deployments in the first place, because it creates three massive critical problems for us down the road. Okay, so first off, there's zero self-healing. If that progress pod crashes or gets deleted, it's just gone. Our Toto app is now calling a dead end. Second, pod IPs are what we call ephemeral, which is a fancy way of saying they don't stick around. When a pod gets recreated, it gets a brand spanking new IP, and our hard-coded link is instantly broken. And third, what about scaling? If we want 3 progress pods for redundancy, we now have 3 different IPs. Which one are we supposed to hardcode? And this just shows you the problem in action perfectly. Our original pod is running at .34. Someone deletes it. A moment later, Kubernetes does its thing and creates a new one to replace it. But look, it comes up with a new address, .37. Our to-do app is completely clueless. It's still trying to call that old, non-existent IP. And just like that, our application is down. So we need to move on to the real solution. We need a stable address, something that doesn't change every time a pod blanks. And that, my friends, is exactly what a Kubernetes service is for.
Honestly, the best way to think about a service is like a permanent P.O. box. The actual pods are like people who move houses all the time. You can't just mail a letter to their house because the address will be different next week. The service is that single, unchanging P.O. box address. You send all your traffic there, and Kubernetes makes sure it gets delivered to the right pod no matter what its current temporary street address is.
Now, services come in a few different flavors. For our setup, ClusterIP is perfect. It creates an address that's only reachable from inside the cluster, which is all our progress app needs. Then for the to-do app, the thing we might want to hit from our browser, we could use something like a node port to expose it for testing. Okay, so the service solves our networking problem. We have a stable address. But what about our self-healing problem? What ensures our pod is even running to receive traffic in the first place? For that, we need the other hero of our story, the Kubernetes deployment. You can think of a deployment as a guardian for your pods. Its job is actually pretty simple, but it's incredibly powerful. You just declare your desired state, you tell it what you want to be running, and the deployments controller works around the clock to make sure the cluster's actual real state matches what you asked for. For example, we can just tell our deployment, hey, listen, I want 3 identical copies or replicas of my progress app pod running at all times. No more, no less. And this is where the magic really happens. Let's say one of those pods just dies. It crashes, someone deletes it by accident, whatever. The deployment controller immediately notices, whoa, wait, the desired state is 3, but I only see 2 right now. So it automatically and instantly spins up a new pod to bring the count back to 3. That right there, that's self-healing. All right, time to put all the pieces together. Let's see how this combination of a service and a deployment creates a complete, robust, self-healing application. We can finally leave that fragile IP-based mess in the dust.
So here it is, our final elegant architecture. First, we have a deployment that's managing our progress pods, making sure 3 replicas are always up and healthy. Second, sitting right in front of them is our ClusterIP service, giving us that single stable DNS name like Progress Service. And now our to-do app is simply configured to call that stable name. No more fragile IP addresses.
So think about the power of this. Now, if a progress pod dies, the deployment replaces it in seconds. The service sees that new pod come online and automatically starts sending traffic to it. The to-do app, it doesn't even notice anything happened. There is zero downtime and no one gets a pager alert at 3 a.m. It just works.
And this quote really captures the whole philosophical shift of Kubernetes. You stop thinking imperatively. You stop telling the system how to do things. Instead, you work declaratively. You just describe the end state you want, and you trust the system to do whatever it takes to make it a reality.
And this is just scratching the surface. This powerful desired state model applies to so much more than just running pods. It's how you manage configuration, handle secrets, provision storage, the whole shebang. So the question I want to leave you with is this. Where else in your own projects can you stop micromanaging the individual pieces and start declaring the resilient system you actually want to build?